Hello and welcome to today's webinar. My name is Jeffrey Palermo, and as we get started, the Zoom software is what we're using here, and it has a Q&A window. And by the way, if someone wouldn't mind putting in the chat window that my audio is coming through loud and clear, just want to make sure that I sound great for everybody. We've got a great crowd today. I'm excited to give the webinar, and just from the I appreciate that, Andre. Just from the attendee list, we have a good group of software leaders, architects, senior developers. We have some executive technical management, and I'm really excited to present this topic today, a DevOps roadmap for software releases in hours. As we go through here, you can use the Q&A window and put in any questions that you have, and I'll try to work them in as we move through the webinar. And if I don't get to any questions, then my commitment to you is that I will make sure that I answer the questions at the end. And also, I'll be talking about a few different resources as we go through, and Rain is assisting me with this webinar, and she'll put in some hyperlinks into the chat window so that you can get those resources. So let's get into it. So again, my full introduction. My role is the Chief Architect here at ClearMeasure, and we are a DevOps-Centered Software Engineering company specializing in Microsoft and cloud software. And I'm here to present a DevOps roadmap that can help enable your team to move fast, build your software in a smart manner, and run your system with confidence. So regardless of the challenge that you might be facing today, as a leader, you have a really important responsibility to guide your team. And my hope for you is that you'll be able to take away some information that can help your project succeed. I really believe that every software team can be world-class. And that's my hope for you, and equipping them appropriately will help make that happen. So let's get into the agenda. The webinar is organized like this. We're going to talk about some of the challenges that we typically face, some of the symptoms and possible root causes hiding behind those symptoms, a roadmap for accelerating your release cadence, and then dive into the details of every section and phase of that, and then talk about some of the value that we've provided for other clients, and offer some assistance that we can provide. So we have a free offer for anyone who is attending this webinar. I've recently finished my latest book, which is called .NET DevOps for Azure. We have the preview edition that's available directly from the book manufacturer, which is lulu.com. We're going through the final proofing stages in order to get it distributing on Amazon and barnesandnoble.com and all those. But we launched it at the Microsoft Build Conference, and we distributed about 400 copies just at the conference alone. And it's amazing how many people are buying it, because I think this topic is really needed. And so go ahead and you can either email me directly for a free ebook version of the book, or you can go to the website if you want a full print copy. All right. Okay, another resource that'll be interesting, I'm sure, to a lot of people is the Azure DevOps podcast. I'm actually the host of that podcast, and you can go to www.azuredevops.show. There's many past episodes and guests. There's guests who work on the actual DevOps products at Microsoft. There's guests who have achieved quite a bit in their software systems, and they're sharing their success stories. And so quite a few industry leaders that you'll probably recognize their names on the guest list. But just go to the website and you can see all the past episodes. You can subscribe on any podcast directory that you might use. Okay, so we all want the same thing. Let's go through the challenge. We really do want the same thing. And I'm going to shrink myself here. the challenge is our cycle time. The challenge is our speed. We all want high speed, high quality software delivery. If we have the high speed without the high quality, then we're just promoting defects to production at a faster cadence, and we don't want that. And so if your cadence is measured in months or even weeks, you probably are seeing other folks that are other teams, other companies that have days, hours, or minutes in their cycle when they can deploy something or deploy whenever they want on demand. And that is the challenge in front of us. Now, what's keeping us from being able to deploy whenever we want? Because we want to move at the speed of business. We don't want our business counterparts basically asking, okay, when is technology going to be finished? How long do we have to wait? So some of the symptoms that we face, what it might look like, are disruptive, error-prone deployments, or long lead times, things just taking a long time and really not understanding why. Or we think that we're 90% complete, and then, oh, lo and behold, now we were tracking to 1 more week, and now we're tracking to 4 more weeks just instantaneously. And it's really frustrating. But some of the root causes that typically lie under here across so many of our clients is the 3 on the bottom right. And an insufficient work environment is a common root cause in software development. And if we don't have everything necessary in this digital software factory that we're operating, then our teams are not going to be able to get their work done. Also, the software process that everyone's going through and mapping out every phase of it, that's really important. And oftentimes we find an incomplete software process as well. When it comes to managing risks and seeing where we are, measurement is we find very common, lacking or not complete. And so you can think about your situation and guess or decipher whether some of those root causes may be present in your situation, or what other symptoms you have as well. Now, this is a conventional view of DevOps. And in this view, it's that we set up an automated continuous delivery pipeline and then work in short cycles to move software features and changes from idea and analysis out to production and real usage. And that's important, but that's only the start. And that's why we have the automated DevOps pipeline not fill the center of the cycle, but it's a small part, and it is the axle around which the cycle can spin. But it's only the start. It's only the beginning. There's 3 ways of DevOps, and if you've read the Phoenix Project, you know that the first way is flow, the second way is feedback, and the third way is continuous learning. And so the automated DevOps pipeline, when you just kind of implement it and get it going, it's just automating the flow. And you could end up with a situation where you're accelerating the rate of defect delivery to production if you don't put in feedback or continuous learning. But let's just touch on the basics of that pipeline before we move on to what else needs to be in the mix. All right, now this is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy. It has a continuous integration build and a 3-tier deployment pipeline. And by the way, you'll never have fewer than 3 environments, even for simple applications or microservices. We've done some other talks and webinars that deep dive into the technical details of this model. And please reach out if you need more information on how to set up a software system for continuous integration and automated deployments. We do a ton of that work. Not just the front end of the application, but also the database is just as important. And if you would like the full architecture diagram, so you can read the words, and this is only actually the top 1/3 of it. It's about a 2-foot by 3-foot poster. Then you can go ahead and request that, and we'd be happy to send it to you. All right. So now I want to talk about the challenge that our software industry has and why this model is appropriate. So there's this new business owner that wanted to start a new auto mechanic shop. And so he um, buys a premium piece of real estate on a really good location, lots of natural organic traffic, and builds a beautiful new building, thinking, you know what, I'm going to do this right. Only the best will do. Great location, great building. He goes to the local auto mechanic training school, which is about to have a graduating class, talks to the dean of the school and says, I want to hire the best of the best from your class, only the top tier of this graduating class. And I'm going to pay him what it takes to get the top mechanics. Only I want to do this right. And he buys some beautiful new tools and Snap-on equipment, thinking, you know, I'm going to equip my people properly. I'm going to buy the right tools and give it to them. And so graduating day comes, and then these newly trained mechanics, really smart, really excelled in the program, are out in front of this beautiful new building, great location, with all of this new equipment kind of on pallets there. And the owner says to his new team, okay, I'm really excited. The customers are going to be here soon. Let's go ahead and get set up so that we can do our grand opening. And he's grinning ear to ear, and he walks away really proud of himself and excited about the future. And his new team, this top layer of graduates from the auto mechanic school, they look at each other, eyes wide in fear, trembling, because they have no idea what to do. They were never trained in how to set up their own shop. They were trained in an environment that was professionally set up for them. And in the software world, it's the same thing. If you've been doing software for probably over a decade, then you remember the on-the-job training that you had in order even just to set up your own environment, set up new systems, set up environments, everything that goes with being effective. And our education system does not train the new people in how to do this. It kind of trains them on a few technologies and some principles and some techniques. And it really is up to us as software leaders to provide them the complete work environment, to equip them not only just by buying them tools, but organizing everything in a way where they can be effective. And that is our challenge. And when we talk about a complete DevOps environment for moving fast, this is what I'm talking about. And it's much more than just configuring a build and deployment tool to do compilation, stamp version numbers, and deploy files out to servers. There's more that's necessary. And our model illuminates the missing layers that enables DevOps-centered software engineering. And so that's what we're diving into now. Okay, so we have these various layers, and there's 5 additional layers along with the actual pipeline, the automation. We need to have best practices, defect removal, team workflow, architecture blueprints, and cloud operations. Now, of these layers, each must have a sound strategy, be executed with discipline, and have objective measures. It's not enough to say that you've equipped your team with defect removal, for example, if you don't specify what that is. Your strategy is the selection of defect detection methods. And we benefit from software research. For instance, I'll reference some research by Capers-Jones, and he spells out the combination of defect detection methods that are proven to achieve the needed quality. But the strategy portion takes the guesswork out of the process for our team. The strategy is choices of what we are going to do and what we are not going to do. And then our team executes a process that consistently implements that strategy. And then we have measures so that we know, through the consistent execution, so that we know that the strategy is working, that it's producing the right objectives. So let's quickly touch on the layers that make up this complete DevOps work environment. Now, one example, and by the way, each of these layers, I illustrate some of the examples on the left-hand side, not a comprehensive list by any means. And then what a common beginning state that we see, for instance, in best practices, you may be in a situation where your practices are not explicitly stated that they're not strategically selected. You don't have any controls to make sure that they're actually happening. Maybe you had a conversation a while back, but you've had some new team members or people don't remember. But the ideal state is that the selected practices are chosen strategically, the controls are in place, they're happening. Okay, so the one example best practice commonly selected is the use of stable reusable components. Now that's just one of them. Now, by the way, there are so many practices out there that have been labeled as quote best practice that it is logistically impossible to use all of them at the same time on a given project. And so the question is, okay, I have a lot of really good practices. Which ones am I going to use for this project? Which ones are the team going to implement to be effective on this particular project? Because we're not going to use them all. We can't use them all. We have to pick. It's a choice. That is the strategy portion. So one example, best practices is buy versus build. That essentially in research is called using stable reusable components, but that's buy versus build. That's, this practice, it has some data in the research that it drastically cuts down on custom development costs. And in the .NET world, these are NuGet packages. In the JavaScript world, these are NPM packages. But even among teams that have declared that they do this, a lot of times when we go in and look at the applications, we find large sections of code that could have easily been replaced by one of these packages, whether open source or commercial. And we find that the team managers are often unaware of the missed opportunities to save significant chunks of schedule. They were unaware of the existence of said code. Now, this happens the same with DevOps automation. We go in and we look at how someone's put together a pipeline, and they don't use the capabilities of a particular product, and we find just pages and pages and pages of PowerShell script that have been put together instead of just using what's available, as opposed to custom automation and just loads of custom scripting. And if someone's not aware that something's available, or they don't have a process that kind of goes through the investigation and discovery to see what's available, then the code base is going to end up with way too much code that could have been saved by just reusing something that's out there. So the next layer is defect removal. Now, again, there's some practices for defect detection and removal on the left. You're not going to use all of them. There's too many techniques and to use all of them on a given project, but research shows that far less than half of the defects are defects in code. So there's a distribution. For every 5 defects that are in a software system, 1.75 does come from code, but 0.4 of them, which is almost 10%, comes from bad fixes, and 0.6 is problems with documents, but 1.23, which is, almost 30%, come from design errors. And then 1 out of 5, which is 20%, comes from requirements gaps or faulty analysis. And so this research is synthesized by Capers-Jones. He has a 2012 white paper called Software Defect Origins and Removal Methods. Again, that's Software Defect Origins and Removal Methods. And you can just search for that, and it's a PDF you can download. And you can use that to help figuring out what your defect removal strategy is, because every software system has defects, and we even have research on defect potentials based on the type of software, how many defects we should expect across the life of the software. So it's a lot, and we have to have a process that detects them and then removes them. So based on the type of the software we have, we need to strategically select the defect detection methods and how to remove them that are shown in the industry research to get us at least to 85% defect removal, and then up in the high 90s. And you for yourself can calculate just how many defects that would still flow through to your customers, because it's pretty sobering. and then measure as those methods are applied to ensure that our teams achieve this level and then maintain it. And interestingly enough, unapproved reused code from external sources, that's actually in the short list of major defect origins. Capers-Jones also has a short list of top 10 causes of defects, and just reusing code that's not really vetted, that's not stable, that's actually a major cause of defects. And of course, anybody can publish a NuGet package. Microsoft doesn't have a process for vetting it. Same with NPM. So you really need to know that you're getting those from a reputable source, especially if they're open source and not commercial, and you don't have a support contract. But NuGet, it's great for packages strategically identified, but many teams do find that there's extra packages in there that are a surprise, that somebody went and just grabbed something and now it's part of the system. If you look in the chat window, we have the URL to that white paper, Software Defect Origins and Removal Methods, for those of you who are interested. Now, the next layer is team workflow. Most software project tracking tools use swim lanes or columns in a Kanban board. These are statuses to move a piece of work through the process. But when we work with our clients, we find that the tracked process is much less granular than what actually happens in real life. If the motion in the team, and I'm using kind of lean manufacturing imagery here, but if the motion in the team doesn't reflect or doesn't show up that way in the work tracking tool, then you're going to have bottlenecks that happen and they remain hidden. They're going to sap your schedule. Your complete workflow, when you completely model it out and it shows in whatever tool you're using, it sheds light on every bottleneck source and enables a team to have a constant, predictable flow that can be tuned and measured. Imagine a factory floor. In manufacturing, factory floors are designed to minimize unnecessary motion because that's waste. It's the same thing in a software process. Now, we're not creating a factory that's cranking out the exact same thing. We're more akin to a fire engine factory, or I've also read about Corvette factories where it's a team-based manufacturing process, where for a fire engine, there is a team that takes a fire engine from original design all the way through delivery, as opposed to passing it down the line, because every fire engine is unique. No two fire engines are the same. And so you can't just mass produce it like you can with, say, a Toyota Camry. So essentially, we are putting together some type of digital assembly line, and we need to have a complete workflow and have all of those things accounted for. There's at least four distinct types of design that happen before any code can be written. And if those four distinct types of design decisions are not made ahead of the code, then whichever engineer has his hands on the keyboard is going to try to make decisions, and the decision may be different depending on who's trying to write the code. So the next layer is architectural blueprints. Philippe Christian in 1995, he was at Rational Software Corporation at the time. He published a method called the 4+1 view model of software architecture. And you can Google for that. It's a PDF you can download. The 4+1 view model of software architecture by Philippe Christian. And it's probably still to this day the best model for iterative emergent architecture. And we use it at ClearMeasure. And the premise is that you're not going to just kind of have one architecture and boom, it happens. It's that you have a vision for an end-state architecture, but every increment along the way, there is an architecture for what it's going to look like at that increment. And so you have lots of transitional states. And I think that's the real world. Now, to determine how your team is going to maintain architectural blueprints, on the strategy side, you're defining what is being built. what is cleared for investment, and what's deferred. Every professional that builds something uses design drawings and design models in the communication of what is to be built. And teams that lack this are constantly struggling to place the same image in the minds of each team member. We often ask when we go into new clients, we ask about how the system is structured, and far too many times we spend over an hour in a conference room harvesting the architecture out of the heads of the team members and drawing it on a whiteboard. Because you ask, hey, do you have some architecture diagrams? And if they do, they say, oh, well, these are woefully out of date. There's a lot that's changed. And so we have to get an understanding of what the shape of the system is. Architectural blueprints as a concept is the definition of what is to be built and what you have. And it's a tool for team alignment. With the 4+1 view model of software architecture, it calls for a minimum of 4 basic layers of blueprints for your system. Just like a house is going to have the floor plan, but then it's also going to have an electrical view, a plumbing view, an HVAC view, things like that, even a structural view for the foundation. So in software, we need multiple views. Yes, we need the physical or runtime view, which is, hey, what's the computing environment or the servers or the cloud services that this is running on in production? That's the runtime view, or physical. It was physical in 1995. Now it's all virtualized. So it's the runtime view. How is it running in production? Then the next is logical. Logically, regardless of what pieces run together, what are the pieces or modules of the software system and the dependencies between them? The next layer is the process view or data flow. And that is for common transactions, what is the order of the data flow between logical modules in the system for key transactions? What direction does the data move as, say, a user invokes a function or clicks a button? And then the fourth layer is the development layer, which is what is necessary in order to maintain, operate, and grow this system. And that is where all of the DevOps environment is specified, which is in the development view. What does the structure of a developer workstation need to be? Build servers, pre-production environments, all that. All right. Next layer is cloud operations. And operating the software system is how we deliver value. It's how we get it out to the people relying on it. And when they have problems, we need to operate it well and know what's going on. If we rely on a user to report an issue, we are only capturing a subset of the information that we need or is available. Through how we set it up, we should see that a user is struggling, much less received an error. And many teams have logs. Every software system has some types of logs, but not enough. And it's a problem when an admin, someone with administrative access, has to log onto a production server to look through those logs. And we find that there's no aggregation, no performance timings. The goal here is to make the software system completely observable, to know what it's doing. There's three types of telemetry that need to be emitted from a software system in order to achieve our observability goals. The first one is logs, which is just kind of extemporaneous lines of, oh, this happened, that happened, this happened. Information is typically free form. Every system has it because it's been the common type. The second type is events, which is cataloging when each function is starting and finishing, transaction types, and those are typically named, unique names that can be aggregated. And then the third is metrics, and these are numbers. These can be aggregated, these can be summed, averaged, min, max over time, and they are numerical in nature, so that we can use business intelligence techniques like grouping and using aggregate functions to produce information out of what the system is doing. And ultimately, we're centralizing all of that information into a single place that could be queried using actually the same business intelligence techniques and tools that perhaps the business partner use if you operate a data warehouse or even a reporting database. So that is the model for DevOps-centered software engineering to help you move fast, build smart, and run with confidence. All the various layers. It does start with your automated DevOps infrastructure. Azure DevOps Services is a premium product there. For VM-based systems, Octopus Deploy is king of the VM-based deployments. And then, of course, they have some overlap. They integrate really nicely together. But for each of these layers, we need to have a good strategy. We need to make our choices of what we're going to do. Then we need to execute it consistently and then measure to make sure that our strategy is yielding the appropriate results that we're looking for. Now, we've seen tremendous results, and we've seen this model make a huge impact for our clients. We have some client success stories available on our website. Pop Hutchison is the largest property tax firm in Texas, and we help to equip them with a complete and professional work environment for their software team and a strategically determined process. And they went from up to 4 weeks per deployment or per release to literally hours. And in their world, that's actually faster than their business needs them to go. So they are moving at the speed of business. We hear of teams who move fast at Google, Netflix, Microsoft, but any of your teams can be just as effective when equipped properly. They really can. You've got smart, motivated people, and they just need the right working environment, the right methods, the right tools to truly excel. Now, there's two models that we have for engaging, and our goal for you is to be completely self-sufficient, and that you run everything, and we're just kind of filling in some gaps and assisting you. Another model that sometimes is appropriate to start with is the guided model, where we really come alongside you and help you get through a particular phase until your staff is appropriate, taking it on, starting with setting up all of those layers, including provisioning Azure DevOps services or setting it up with a completely automated pipeline, 3 layers of test automation, static analysis, automated deployments, Azure environment, the proper organization there. So it's our goal to see your team be truly world class, and we equip you to do that. So one of the easiest ways to get some help even is to have us do some architecture level advisement or consulting. And if you'd like a second pair of eyes on your organization, your environment, or your processes, we're happy to help there. Or if you know exactly what you need already, we're happy to take care of it for you. We have a full capability, very, very seasoned engineers and architects all over the U.S. to help you out. I have answered quite a bit of questions. One of the questions that we do have here is the resources in the chat window. So if you open up the chat window in the Zoom software, you'll see some links that are going to come through. And let's see here. I believe they should come through in just a minute. And paste. Okay, so there's a list of links there that are the resources that I mentioned. And I'll go through them just one at a time. The first one we included was a link to the book where you can order print on demand, and you can get it right now, even before it's been released through Amazon. And for coming to the webinar, you get the free ebook. There's a link to request your ebook, or you can email me. Also, there's a link to the podcast and a link to the architecture diagram of a full DevOps pipeline implemented with Azure DevOps Services and Octopus Deploy. And then there's a link for Capers-Jones's white paper on software defect origins and removal methods. And then there's the white paper, actually the same one. Yep. So those are all the links, and I believe that covers it, all the links that we were distributing. So thank you for that question. Another question I didn't fully answer it, so let me make sure I completely answer it now. Is how do I get started? Do I have to have all this in place? What if I've already started on the project? Well, everything in the DevOps world, just like in the Agile world, is incremental. And so the same thing applies here. Start from the middle, do a little bit, and go to the outside. So if you don't have, let's say you don't have even an automated build for your team, okay, set up Azure DevOps services. And by the way, if you're on premise, you can set up the build server internally and just pull down Azure DevOps server, next finish, boom, you've got a build server. If you not doing anything in the cloud or hosted, but just set up compilation as a start to your continuous integration build, and then go to practices, the practices layer, have a meeting with the team and catalog the practices that you are doing now, just to make sure everybody's on the same page. Then move on. Defect removal. What are the things that we're now doing right now in order to find defects and fix them? And then same thing with team workflow. Model all of the columns that need to be in your process. And yes, if there's a department that needs to be checked with, that's part of the process. Give them their own column. Look at any bit of work that is happening by throwing emails back and forth, and instead create a new column on your board to represent that work. Get that work out of email. And then architecture blueprints. Start with a whiteboard. Just draw the structure of your system, and then cloud operations. Identify all of the logs that are there and start putting a plan together to get them centralized. And that's one iteration through your strategy. And then next time around, you want to measure and check if it's being executed and what the results are, and then come back to your automated DevOps pipeline and add some more robustness to your continuous integration build. Add some layers of test automation or static code analysis, or add the beginnings of an automated deployment to a pre-production environment, and then go back to best practices and see if there's an additional practice that needs to be brought into the mix. But iterate through everything. All right, hope that helps. Hope that answer helps. I think I got through all of the questions. I appreciate your time. I know your time is very valuable. My goal was to get you in and out and get this information delivered. And my email address is on here, also on Twitter at Jeffrey Palermo. And we would love to help out in any way we can. Our goal is to make you completely self-sufficient and up-level your team through whatever's whether it's getting you down the road faster if your team is trying to accomplish something in the DevOps realm, or getting things set up properly in Azure. Give us a call, and best case scenario, we can help you out and get you down the road. Worst case scenario, I give you some free advice that might be useful to you, and we've made a new friend. So thank you again, and I hope you have a great rest of the day.